Hey everyone, in this video we are going to be starting our, biggest concept of this whole idea. It's called series. So in the last section we talk about sequences, and if you remember, a sequence is just like a list of numbers in order, like A1, A2, A3, A4, just keeps on going forever. But now we're going to be doing something new. So instead of only looking at the numbers, we are actually going to add them. So if a sequence is a list, then a series is a sum of that list. So for example, let's say you have a sequence of 1/2, 1/4, 1/8, 1/16, and just keeps going forever. So then the series of that would just be the same thing, but you just add them. So 1/2 plus 1/4 plus 1/8 plus a 16th. So the easiest way to remember this is that a sequence is just a list and a series is just a sum of the list. So now we're going to look at how we write series. So this is how we usually write series. So A1 plus A2 plus A3 plus A4 all the way. And the notation we use, it's called a sigma notation, and it looks like this. So the sigma symbol that you see right here in the blue, this means to add. So this means that starting at n equals 1, plug into the function a sub n and add all the terms. So our big question in this video is that if we keep adding terms forever, does the total settle down to one number? And if yes, the series we say converges. If it doesn't, then we say the series diverges. But here's something important. We're not actually going to add all the infinitely many terms at once. Instead, we're going to add the first few terms, then a few more, and watch what happens to the running total. So this is probably the most important concept in this section. So now we're going to be moving on to a concept called partial sums. So a partial sum, we just say, is just a running total. So what this means is that I'm going to write out some partial sums here, then I'll explain what they mean. So this S right here, actually let me finish this really quick. So this S sub n means the sum of the first n terms. So for example, let's look at this right here, the S sub 3. So this would mean S sub 3 is the sum of the first 3 terms. So the sum of the first term plus the sum of the second term plus the sum of the third term. Sorry, I'm stuttering. Plus the sum of the third term. And here is a definition. I would write this down for a convergence for a series. So I'm going to box this in red really quick. So this means that a series converges to L if its partial sum approaches L. So when we study the series, we're just really asking ourselves, what are the partial sums doing? So a lot of people get confused, so let me try clearing this up. So in a series, there are two different things. There's something called the terms, which are the pieces you add. So for example, like this, you add for third partial sum, you're going to add the first, second, and third term. However, and then there is a partial sum where these are the running totals. So Let's do an example really quick to clear this up. So for example, let's say a series, we have 1/2 plus 1/4 plus 1/8. So the terms would just be 1/2, 1/4, and 1/8, right? However, the partial sums would be 1/2, 3/4, 7/8. Now you're probably asking me where I got this from. I just did it in my head. So remember, if you remember, a partial sum is just whatever number you're looking for the partial sum, you just add those terms. So for example, if you look at right here in red, s sub 2, for this, if you want the sum of the two partial terms, you add the first one and second one. So I just went ahead and did that and just wrote them here just to show you different that the terms and partial sums are two different things. So don't get confused. So now we'll be moving on to our first main concept, which is called the geometric series. So a geometric series is a series where each term is found by multiplying the previous term by the same number, and that repeated multiplying is called the common ratio. So let's do an example. So let's say we have this series, 2 plus 6 plus 18 plus 54 plus, keep on going. So if you can see, this is a geometric series because you multiply each term by 3, right? How do you go from 2 to 6? Well, got to multiply by 3. How do you go from 6 to 18? Again, you multiply by 3. How do you go from 18 to 54? You multiply by 3. So if you can see, the common ratio in which we multiply all of these by is 3, and we denote that as r is equal to 3. So let's do another example really quick. So let's say we have a series, 1/2 plus 1/4 plus an 1/8 plus a 16th. So let's see if this one has a common ratio. Well, to get from 1/2 to 1/4, you have to multiply this by 1/2. To get from 1/4 to 1/8, you also multiply by 1/2. And lastly, to get from an 8 to a 16th, you also multiply by 1/2. So in this case, the common ratio is 1/2, so we're going to write that as r is equal to 1/2. So I would write this next thing down. So we typically say that a geometric series has a general form. So write this down here. Geometric series has a general form a plus ar plus ar squared plus ar cubed plus infinitely, where we say that a is equal to the first term and r is the common ratio, and r is equal to the common ratio. So go ahead and pause the video and write this down. But what I mean by the first term, so let's look at this example right here, the first one. The 2 plus 6 plus 18 plus 54. As you can see, the first term right here is 2. So in this case, in this example, a would be 2, and our common ratio, as we found, is 3. So our r would be 3. Hopefully that makes sense. So now we're going to see how to find the common ratio. So to find the common ratio, you divide one term by the term before it. So let's go back to this example right here. I'll draw an arrow in blue. So we're going to be using that example. So remember, we have to divide one term by the term before it. So let's start with 1/4, because if you use 1/2, there's no term before the 1/2, right? So our r would be equal to 1/4. So that is our term, and then we divide it by the term before it. So what's before 1/4? Well, as you can see in the series, it's 1/2. Now we just simplify. So to simplify this, you can just multiply by the reciprocal on the bottom. So multiplies by 2 over 1. Multiplies by 2 over 1. So r is equal to 1/4 times 2 over 1, which is equal to 2 over 4, which is also equal to 1/2, which that's what we got right here earlier. So this is just a general formula to find the common term if you can't just see it right away. is you just divide a term by the term before it. Just remember not to use the first term because there's nothing before always. There's always nothing going to be nothing before the first term. So I'm going to go ahead and erase all this. So if you need to, pause really quick and write this anything down if you need to. So what we just did is we just laid out the basic of a geometric series. Now we're actually going to go a little bit more in depth for the geometric series. So here is the big rule. So I'm going to write this down in red. A geometric series converges only when the absolute value of r, or the common ratio, is less than 1. So what does this mean? Well, as you learned from the previous video, when something converges, it means it approaches a number. So we're going to say that in this case, a geometric series will converge only when the absolute value of the common ratio is less than 1. And so on the bottom, if that happens, then the sum is so the sum would be this. Remember, this is just the sigma notation right here for the geometric series, and if you remember from earlier when I talked about the form is a plus ar plus ar squared plus ar cubed, so you're just adding up all the terms, so the n just means the n number. So that's just a general formula for geometric. So basically what it's saying is that if your common ratio is less than 1, then the sum of that geometric series is going to be equal to a, remember, which is the first term, divided by 1 minus the common ratio. So here's a good rule to remember. I'll write this down. I'm also going to be writing this in red. So remember, if the absolute value of r is less than 1, the geometric series converges. And then if the absolute value of r is greater than or equal to 1, the geometric series diverges. So this rule matters because it gives us a whole class of series that we know how to solve immediately. So now we are going to be moving on to our second main concept, called the divergence test. So this is the other major idea in this section. So, this is a quick test, pretty quick and easy test that you learn for series. So this is what the divergence test this is what the divergence test says. If the limit as n approaches infinity of a sub n does not equal 0, then the series must diverge. And we also call this the nth term test for divergence. So let's think about why this makes sense, right? Let's see what the series is doing. So you know that in a series you're just adding a term after term after term forever, and if those terms don't go to 0, then you are never really adding tiny leftover pieces. So there's no way that your total is ever going to settle down, right? So for example, let's try adding 1 plus 1 plus 1 plus 1 plus 1 forever, forever, forever. As you can see, these don't go to 0, so the total is just going to keep growing. Or let's look at this. Let's say we had 2 plus 3 halves plus 4 thirds plus 5 fourths. So as you can see, these terms are getting closer to 1, but not 0. So again, you're still adding like pieces forever, but the total is not going to settle down. So the divergence test is just a really quick test of saying that if the terms themselves don't go to 0, then you stop immediately because the series diverges. Now, we're going to be moving on to our first example. So, we're going to have the series. We saw this one before. A half plus a fourth plus an eighth plus a 16th. So, our first thing we're going to do is check if geometric So, let's see if it's geometric. Well, if you remember from earlier, if something is geometric, it's going to have a common term that these are being multiplied by. So, if you can look at this series, to go from 1/2 to 1/4, you know you multiply by a half. To go from a 4 to 8, you know you multiply by a half, looking good so far. And to go from an 8 to a 16, you also know you multiply by 1/2. So, that's good. So, we know our series is geometric, and our common ratio is r equals 1/2, and our a, which is, remember, the first term, so the first one of the series also coincidentally 1/2. Now, let's check the convergence rule. Remember, a geometric series converges when the absolute value of r is less than 1. So in this case, our common ratio is 1/2, so is the absolute value of 1/2 less than 1? The absolute value of 1/2 is just 1/2. So is 1/2 less than 1? Well, according to me and according to math, it is. So yes, 1/2 is less than 1. Therefore, we can use a geometric series formula to find the sum. And remember, the formula was a over 1 minus r. So as you can see here, here is our a, and here is our r. So let's plug it in. So we're going to get, whoops, I'm going to use blue. So 1/2 over 1 minus 1/2. So a whole minus a half is just a half, so we're going to get that equal to 1/2 over 1/2. And any number divided by itself is just 1, so the sum for the series is 1. Therefore, we will say that the geometric series, this is geometric, and does converge to 1. So the sum of the series is 1. Now, let's look at our next example. So we're going to say we have a series 3 plus 6 plus 12 plus 24. So let's check whether this is geometric. So how do we go from 3 to 6? You know, we multiply by 2. How do you go from 6 to 12? We also multiply by 2. 12 to 24, we also multiply by 2. So we know that this is geometric. So this is geometric. We're going to say, so our a is equal to 3. Remember, our first term is a. That equals to 3. And we found our common ratio, or r value, to be 2. Now, let's check the rule. So, is the absolute value of 2 less than 1? Remember, the absolute value of 2 is just 2. So, is 2 less than 1? Well, since 2 isn't less than 1, therefore, we'll say the series this will diverge. So this diverges because our common ratio r is not less than 1, and we know from our definition of a geometric series that if your absolute value of r is less than 1, if your absolute value of r is greater than or equal to 1, the series diverges. So in this case, the series will diverge. Now, let's move on to our next example. So say we're going to have if n equals 1 to infinity of n plus 1 over n. So we're going to use a divergence test on this one. So for here, we know our term is just going to be this right here. So we're going to write that as a sub n is equal to n plus 1 over n. So let's simplify this so we can split up the fraction. So this is also n over n plus 1 over n. Simplify this more, n divided by n is just 1. We can just leave that as plus 1 over n. Right? Now we take the limit. So the limit as n approaches infinity of 1 plus 1 over n is equal to, well, what is 1 divided by infinity? A small number divided by a huge number is just 0. So that's going to leave us with 1 plus 0, and 1 plus 0 is just 1. Therefore, the limit as n approaches infinity of a sub n is equal to 1. And if you remember earlier, since the limit is not 0, the series diverges by the divergence test. So the series diverges by the divergence test. So this is when we use the test. So as you can see, n plus 1 over n, this is not a sequence, right? This is like a series, so we can't really find a common ratio or anything. So if you can't test for geometric, we go to divergence. And from the divergence test, we can say this is a quick way to show that the series can't converge because the terms do not go to 0. So this is the last example. This one might be a little confusing, but over time, when I make more videos and everything, you'll understand this concept more. But basically, I just wanted to show you that there's this series called a harmonic series, which is 1 plus 1/2 plus 1/3 plus 1/4 plus keeps on going. So this series diverges, even though, if you even recall, this is the harmonic series also called 1 over n. And as you plug in more and more numbers, 1 over n does go to 0. However, even though the terms do go to 0 as you plug in bigger and bigger numbers, but it's not enough. So the divergence test can prove divergence when the limit is not 0, but it can't prove convergence when the limit is 0. And that's a little bit confusing, but we will explore this idea later throughout the video series, but hopefully we'll clear this up soon. So now we're going to go back to the main formulas and rules. So as you know, let's write this down. So what did we learn? We learned a series notation formula, which is just the sigma of n equals 1 to infinity a sub n. This is the series notation. We also learned partial sums, and that is just sum of n terms are just a1, a2, a3 plus all the way to a sub n. We also learned definition of convergence. We have then we learned the geometric series form. was just a plus ar plus ar squared plus ar cubed. And remember, you can also write it like this. And then you know the common ratio is just r is equal to the next term over the current term. And then we learned the geometric series rule. Which was, if your common ratio is less than 1, this converges. And if your common ratio is greater than or equal to 1, series diverges. And if it does converge, the sum, write this in the arrows, is just a over 1 minus r. And lastly, we learn a divergence test. Which is the limit as n approaches infinity, a sub n does not equal 0, then the series a sub n diverges. So if you didn't write this down earlier, you can take a moment and pause this and write this down. So now you're going to be learning about how to think about solving these type of problems. So here is like I'm sorry, like the title's not like aligned to center. That's my fault. If it throws you off, I'm sorry. You can blame me in the comments. But here's a clean process you can use. So first thing we want to do is we want to identify the series. Well, for now, we only learned 2 types of series, geometric and divergence, but it's pretty simple to tell between the two. Do you see, is there common terms? Is there like a sequence where you can find a common term? If not, or did it look like something where you couldn't find a common term, then maybe use divergence. Then, so after identify, you want to ask what are the terms? Or we also call this a sub n. Then we want to ask ourselves, what are the partial sums doing? Then after we do that, we want to check if it's geometric. If it is, remember, define your a and r values and you use the rule and stuff. So number 5th, if the terms don't go to 0, if terms don't go to 0, then use the divergence test right away. So basically the main tools in this video or section is just your geometric series and your divergence series. So it's a quick little recap. A series is the sum of the sequence. A series converges when its partial sum approaches a number. Remember that limit formula? And then the first big type of series we learned was a geometric series, and we learned that a geometric series converges when the common ratio or the absolute value of r is less than 1. And the other type of big series we learned is a divergence test, which says that if the terms do not go to 0, the series must diverge. And if the limit does go to 0, then we don't really know what happens. We have to do more work, which we will learn more throughout the series of the video series. Sound a little awkward? But yeah, hopefully you learned something new today. Hopefully it helped someone out. And if you have any questions or would like me to explain any more concepts in more depth or detail, you can write down in the comments. But have a blessed day. Thank you so much.